Hello, hello, hello. How are we doing? How is everything going? How is the reading? Please study. Please study. Please study. Test the quiz is coming up very soon. Please study by Friday. Sorry, it's on Saturday, 21st. Yeah, Saturday, 21st of October from 5 p.m. to 12 midnight. 5 p.m. to 12 midnight is just an hour, but 5 p.m. to 12 midnight is the window that has to be opened for because of time, how, like, just because of our busy schedule, you understand? So it's always open between 5 p.m. to 12 midnight, and then would have the test. This is 1 hour. It's going to be easy, it's objective. So success, good luck, and everything. So today we are going to be talking about patch management and Windows operating system. So the last class we talked about the basics of operating systems, the components of operating systems, the functions of operating systems. We dived into these things. We basically saw how operating system can enable multitasking. You understand? So now we're going to dive deeper into patch management. So what exactly? So look at our objective. So our objective today is understanding the basic concept of patch management, its importance, and the patch management process, identifying the types of patches, highlights the challenges and the best practices for patch management, understand the Windows operating system and its components, identify the different system management and diagnostics tools in Windows OS. All right, let's get to it. So, what is patch management? Patch management is the process of identifying, acquiring, testing, and deploying software patches to computers and networks. The patch management is important for keeping systems up to date and secure. So basically, first of all, what is patch? If you, let's say, a part of the road spoil, and you say, oh, I'm coming to patch this road. What does it mean? We're trying to fix up something, right? Yeah. So patch management is basically checking for vulnerabilities, checking for bugs on a particular software, and updating it when the developers of that software release an update for it. So basically, patch management involves that you identify that, okay, this system that I'm using, this application that I'm using, this computer networks I'm using, all them they require patches. There is something that needs to be done, and then you go and check, okay, the developers of this product, have they released an update? And when you find out that, oh, they've released an update, what do? You download it. And then you first of all test it, obviously. You don't just put it into your environment, because sometimes, right, bad guys or attackers can use this method to pollute or to spread a virus. So you have to first test it before you now deploy it into your production environment. So that is basically what patch management is. Now, it can be complex and task consuming, but it is essential for maintaining security and reliability of the computer system. There are different patch management tools and services available to help organizations to automate and streamline the patch management process. So just imagine that you're an organization that have like 10,000 devices, you have networks, you have servers, and you need to be doing patch management update for all these devices regularly. So how does this work? You end up using a patch management system to make this work. All right. So, what is the patch management process? Number one, identify missing patches. So, the first step is to identify which patches are missing from the system in your environment. This can be done by using a patch management tool or by manually checking the vendor's website for the latest patches. So you can have a patch management tool where you can use it to check for patches that need to be done, or you need to go to the website and say, okay, I am using this application, I am using Windows operating system, I am using which application? I am using Word application, I'm using this Microsoft Office application, I am using this game application, I'm using this application basically. VLC and US. Is there any update for this stuff? And if there is, right, you need to check, okay, is there updates? Go to their website. Now, most vendors, right? Most vendors send notifications. So, for example, if you are using Microsoft Word or Microsoft operating system, that's Windows OS, you can see that there is an update. You can see that, okay, they will send you a notification that there is an update, right? Do you want to update now? That kind of thing. So most of these vendors actually send notification to their customers that, okay, oh, there is an update, come and update, rather than you going by yourself to go and look for these updates. You understand? Very important. Number two, we need to prioritize patches. Not all patches are equally important. Some patches are critical than others and should be deployed sooner. You understand? So, what are the factors to consider when you are prioritizing patches? Number one, the severity of the security vulnerability or bug that the patch fix. So because performing patches or patch management is a very critical, sometimes time consuming process. You need to prioritize patches so that you don't just go and be doing everything, like, you might not be able to get everything at the same time. You need to actually organize yourself. So number one thing to check is that you need to check for the severity of the security vulnerability. So how do you do that? You check, okay, what exactly is in this update? What exactly am I trying to update, right? Go to the website of your vendor and say, okay, what is inside this update? Is this a security incident? Is there a security incident that they foresaw and decided that, okay, let us everybody have this update to prevent this security incident? If that is the case, that means you need to run, you need to fly, you need to quickly go and do the testing and deploy it. You understand? Because sometimes, right? Let's say everybody, let's use Microsoft because everybody makes use, most people make use of Windows operating system. Let's say, for example, now we have 15 organizations, and all these 15 organizations use Windows OS. And let's say organization A got an attack from the Windows OS. So what do Windows people do? They will quickly look at, oh, what made organization A get this attack, and go and perform a fix up and patch it, and then send out that update to everybody. So if you, organization D, now you are wasting time with your updates, the attackers will know that it's not everybody that are going to update immediately. So they'll be testing to see that, okay, has this one done? Has this one done? If you've not done your own update, then they will attack you. You understand? So that's why you have to check the severity of this vulnerability. You get? Number two, the likelihood of this vulnerability or bug to be exploited, like the likelihood of it being exploited. You understand? So you check, okay, this vulnerability or this bug and they say that they've updated, what is the chances that somebody will use this method to exploit me? What time someone will use this method to perform an exploitation attack? You understand? And the next point is impact. So if you find out that, okay, the possibility of this attack happening is 50%, and the impact to have on your organization is going to be high, or it's going to be critical, then you know that this update or this patch is what you need to prioritize. But if you find out that the likelihood of somebody exploiting this stuff is like 5%, and its impact on your organization is very low or low, then you can now take a step back and look for more important ones first. Okay, because sometimes a lot of these updates might be coming at the same time, so you need to be able to prioritize. Then the next point is acquire patches. Once you have identified and prioritized the patches that you need to deploy, you need to acquire them from the software vendor. This can be done by downloading the patches from the vendor or by using a patch management tool to automatically download and install the patches. So how does this work? When you found out, okay, these are the patches that are missing, these are my priority patches, what do? You go to the vendor's website, you go to the software and download those patches, or you can use a patch management tool to download those patches. The next point of action is to test. This cannot be overemphasized. Testing patches cannot be overemphasized. Before deploying patches, before deploying these updates, to your system, before this way to your production environment, you must test it. You do not get a patch, especially the ones where you download from the company's website, the vendor's website. You don't get a patch and take it directly to your production environment, because there are many incidents that have happened where the attacker puts out a malicious stuff in form of a patch. Many times that's happened, even though the possibility of it happening now has reduced, but many times it has happened that it was a patch that caused a malware, and it was an attacker um camouflaging the malware as a patch. So what do you do? Every organization is supposed to have a test environment that is replica of your production environment. So it should be a duplicate of your production environment. Just like your production environment is live, where your test environment is not live. Usually as a fallback plan. In case of you have your production environment, you can go to your test environment and get it done. And like quickly put your test environment live while you sort out your production environment. But in this case, you're using your test environment to test this the patches. So when you get the patch, when you download the patch, you take it to your test environment, you run this patch, you see how it works. You check just to ensure that there's no disruption of your services, or there's no disruption to your production environment. Now, the next step is to deploy the patches. Once you have tested the patch, you verify that it's working properly, you verify that it doesn't cause any issue, it does not reduce your speed, you've verified a lot of things. Then you can now move this to your production environment. You can now take this software patch and do that to your production environment because you've tested. You can either do it manually, or you can use your patch management tool, right? So the next thing is to monitor patch compliance. Finally, you need to monitor your system to ensure that all the patches have been deployed successfully. This can be done using the patch management tool by manually checking the system for missing patches. So what you do after deploying the patch, that you want to confirm that all the patches have been deployed successfully. There is no patch failed when it was performing, like no patch field when you're trying to perform the deployment operation. Everything worked. You understand? So that's the goal of this point. So basically, there are 6 steps to it. Number one, you identify that there is a missing patch. You identify that okay, there's a need to patch these applications. Number two, you prioritize. You know which one has the highest risks involved. So if I don't do this, these are the risks involved. You understand? So which one that has the highest risk is the one that you handle first. Number two is to acquire the patch. You can download the patch. You can use a patch management tool to get the patch. With test, this one cannot be overemphasized. Testing your patches is very important. You can't just take it like that. Test it first in your test environment or your non-production environment before you go to the next step, which is to deploy. Once you deploy it, you will now monitor. So monitor that okay, everything is fine. Monitor that nothing out of the ordinary happened. Monitor that all the patches are complete and none of the patch failed and everything like that. So that is basically your patch management cycle, your patch management process. And it's a continuous stuff because um there will always be patches. In fact, I don't know which vendor is that. I think it's Microsoft that have patch Tuesday or something like that. Every Tuesday they bring out patches, or every is that every Tuesday or every like last Tuesday of the month. I can't remember. But I know that a particular organization bring out their patches every Tuesday or every Thursday. I can't remember which one it is. But patching that's why we said at the beginning that it's a very cumbersome task and it's a very time consuming task because it's something that takes a lot of time and it happens regularly. It's not like you patch and then you're okay for the next 3 months. You're okay for the next 1 year. When you patch now, before you need another patch will come up. People that use Windows, you can bury witness. All your devices, your data is finishing with updating your Windows. Yes or yes? Yes. All right, so let's move to the next one. All right, so why is patch management important? So why do we do this in the first place? Why don't we just install our operating system and go away? Why don't we just install that software that we need and go away? Why must we continue patching? Why must we install new updates that these software vendors are giving to us? Why must we do that? Number one, to improve security. Patch management helps to improve the security of systems by fixing security vulnerabilities. So basically, what happens is that I give an example. I'll use the example of the WannaCry virus that happened. So you know that the WannaCry virus happened because of an exploit in the Windows, right? And then what happened was that they created a patch and they sent it out to every organization, to everybody that's making use of that particular operating system. But the thing is that not everybody that did it, everybody couldn't do it. So remember, like I talked about, like the process you have to follow to test. Some people were not able to test before they got infected. All this kind of stuff. So the point of patching is that it improves security. So most of the times when they recognize that there's a vulnerability, they create a patch to cover that thing up. You understand? So that you don't get attacked. Number two is increased reliability. So patches sometimes are for fixing bugs. So let's say, for example, they are using Windows that if you press something, everything will now close, everything will now close, everything will now close. I don't know. Some people have some sort of issues like that. They release a patch that okay, oh, this patch is supposed to stop that thing from happening. You understand? So that is called increased reliability, ensuring that this product is now or this system is now more reliable for you. Number three is to reduce cost. So when you omit the patches that you're supposed to patch and you get attacked, you will spend a lot more money. You spend so much money to fix or to reduce, like to fix the incident, to mitigate that incident. So that is why patch management helps to reduce cost, because by the time you patch up and keep on patching up, you become safe from whatever malicious attack happens, and you won't have to pay cost concerning to associated with cyber attacks and system failure, to prevent things like all of a sudden the system will just crash. You say what happened? The system crash. Who crashed you? Why are you crashing? Things like that. Because sometimes when you don't update the system, maybe they fix a particular issue. They saw that okay, if this and this and this run together, this system will crash. So what they did is that they fixed up that issue. So if you don't do that, if you don't do your patches and you now run into that problem, your whole system will crash. That's when the else will be working fine. You understand? And number four is to improve compliance. Um, Organizations are asked by the regulatory bodies to ensure that they implement patches. So, what are the types of patch we have? Number one is that we have security patches. Excuse me. So, security patches are designed to fix vulnerabilities in software that can be exploited by attackers. So basically, security patches are for fixing vulnerabilities. So if you realize, if for example, the what they call it, with the software vendors, right? They realize that okay, in this application that we have, in this web application that we have, realize that our port is open. This port is open. You understand? So we realize that okay, this port is open. So what do? We create a patch that will end up closing this port. You understand? So what they do, what security patches is that it's for fixing security vulnerabilities. When there's a vulnerability here, there's a vulnerability there. When the developers or when the software vendors push out a patch, the goal of that patch is to fix that vulnerability that was discovered. Number two, we have bug fixing. So bug fixing are patches that fix defects in software. So basically, let's say there's an issue, maybe when you try to upload, using an application, when you try to upload a file, it's always giving error. And you're uploading the right file, you understand? So the goal of the software vendor now is to go and fix why this stuff is always giving error when we are uploading the right file. But that is called bug fixing. So it is different Bug fixing might not have any security implication. You understand? It's just that it's not allowing the user to make good use of the application, or it's not giving a good what they call that thing, user experience to the user that's making use of that application. So it bug fixes improve things like stability, performance, and usability of software. So we have performance patches. Performance patches can are designed to improve performance of software. Performance patches make software run faster and more efficiently. So performance patches are more of like things that ensure that the software runs faster. For example, let's say you are using um Windows, let's say Windows, so you're 10 now, and everything is kind of slow. And then you update your laptop, you update your OS, all of that, everything is fast. That is a performance update that was given to ensure that um the right amount of CPU time is being allocated, ensure that right resources are being allocated. The goal of that particular patch is to improve the user experience, is to improve the performance of that particular software. You understand? So the next one is feature enhancement. So let's say they want to add an extra feature, right? Usually maybe in an application, you can upload the application, but you cannot edit it. But now they now add a feature where you can upload and edit the the file you are uploading. Do you understand? So that is enhancement, feature enhancement. So when they want to add a feature, when they want to add an extra something to that particular device, they present an update called feature enhancement update. Then the next one we have is hot fixes. Hot fixes are small, targeted patches that address specified issues, often in response to customer requests or critical problems. So let's say customers are reporting that, oh, we can't do this with your application, we can't do this with your application. So hot fixes are basically updates that fix those specific customers' need. You understand? So if a customer is using an application and they cannot do a particular thing and they keep reporting, a lot of people keep reporting, they create a patch that has an update concerning that particular need or a critical problem that happened. And that one is something that you need to do immediately. It's not something that should take time. Then we have the 0 day patches. So 0 day patches are released in response to newly discovered vulnerability for which there is no known fix. So as vulnerability keeps increase, as research of vulnerability keeps going further, there are things called 0 day. We talked about this in previous classes. 0 day, which is what nobody planned for. You get, like, you don't plan for it, like it just happens, everybody just collects, you understand? So that particular patch is to fix it. So maybe as they are doing research on their, because as you develop a software, you don't just let the way I'm going. You keep on doing research, you keep doing research. So maybe they did research and you just found out that with this way, somebody can attack us like this, or someone can attack this application like this. Quickly, they'll quickly just release an update. Say, okay, to prevent this from happening. So yeah, these are the types of patches. So we have the security patches when there's a vulnerability, then we have the bug patch fixes when there's a defect in the program, maybe something's not working well, they are not updating something, you cannot update something is not working well. Performance to improve the user experience, increase how fast, just the performance generally of this application. Then feature enhancement when there's a new feature, when you want to add something new. Then hot fixes when there's a customer request, that's for hot fixes. And then for 0 day patches, something a newly discovered vulnerability. So for a patch for that. All right. So the next thing is patch challenges of patch management. So what are the challenges? We talked about patches, how to get your patches, your patch management process. We talked about the types of patches. Now, what are the challenges? Like, what will somebody face when they're perform patch management on a particular system or in a particular organization? Number one is that there's volume. Software vendors release a large number of patches regularly. Sorry, on regular basis. This makes it difficult to keep up with the volume of patches that needs to be deployed. So basically, I told you about how patches always come in large numbers, right? And especially if an organization and you have different applications. Let's say you have a Windows server, you have all your Windows devices connected together, you have your network devices, all these devices, and then you now have applications on those Windows devices, applications on those Windows servers. So everything, everybody is releasing patch because you don't want nobody wants to say that it was me that caused your company to go down. You get, everybody's releasing patch, and some organizations or some software vendors release patch every week, every 2 weeks, every month. You understand? So the more it just keeps compiling because everybody keeps releasing patches, and so the volume of patches is plenty. Number two is testing. So normally, if it was that you just need to find the patch, download it, and install the patches, you will say, okay, the work is a little bit less. But remember that you have to also test, and that test is non-negotiable. It's not something that you can say, okay, I will not test this one. The one I don't test is the one that will go and spoil your production environment and everyone will start calling your name. So you have to do what? You have to test. And testing is time consuming. It's time consuming and complex, especially for large organizations, large environments. So you actually need to test. So that testing can be one of the challenges that the network operators or the what they call it, the network engineers, the system administrators, the administrators face when they are dealing with patch management. The next one is deployment. So deploying patches to all systems in your environment can be challenging. Yes, it can be challenging. Deploying patches to all the systems it can be challenging. It's important to plan you have to have a plan in place to deploy patches in a timely and efficient manner. So deployment sometimes, right, when you think about the enormous amount of things that you have to put patches on, right, it's challenging, especially if your environment is that environment that has a lot of applications in use. You have to schedule different times to deploy these patches. This is where the patch management system comes in, right? There is a patch management system. I'm coming. There's a patch management tool. Let me see. There's a patch management tool that can be used, right, to automate some of these processes. So the next one is change management. Change management can involve changes to the system which can be disruptive to the users. It is important to have change management process in place to minimize disruption. So change management in the sense that maybe the patch that you are doing requires some sort of additional configuration on your part. And maybe this additional configuration might lock out some users or something like that. You get. Then the next one is downtime and service disruption. Applying patches may require system reboots or service disruption. You understand? So you have to be careful. Right? That's why, of course, first of all, you have to test it in your test environment so that you can see how these patches operate. But you have to remember that most of anytime you update your Windows, it will ask you to restart. Yes or yes? Yes. Anytime you update your Windows, most of the time it asks you to restart your system. Talk more of servers. So if you restart a Windows server, you know that they are putting their up all the services that are hosted on that server is going to have a certain particular amount of downtime. That's why most like most operators, most administrative units would do their patches in the night time, weekend to be preferable. You understand? So that at least we know that we have less traffic on those particular services that run on a production environment. Now, what are the best practices for patch management? Number one, establish a patch management policy. Develop a documented patch management policy that outlines the organization approach to identifying, prioritizing, testing, and deploying patches. Very important. When I say very important, I mean very important. Because think about it, right? In an organization, you whoever that is in charge, like administrator, will go on leave. The administrator might give birth and want to do maternity leave, want to do paternity leave. My administrator might want to travel. So you can't just put everything in your head. You need to have like a meeting with everybody that is in charge, maybe the system administrator, the normal administrator, the network guys, everybody sit down and decide that, okay, how do we approach patch management? Because patch management is going to be in everything. Apart from the Windows, apart from the devices patch management, we also have server patch management. We also have network patch management. So everybody is supposed to decide and know how are we going to approach patch management and document the process. You understand? Document so that somebody can come into the company, if you employ somebody new, can go to that document and say, okay, this is how we do patch management in this company. You understand? So that's why documentation, making a policy is very important. Number two is inventory and access management. So you need to have an up-to-date inventory of all your hardwares and software assets. You need to have a document, an Excel preferably, that lists out these are your documents, these are all the hardwares you have, these are the different versions. You understand? If possible, you have last updated on it on that document as well. Then you have your software assets. These are our software assets. We are using Windows OS. This is our license. We're using this particular this thing. This is our license. You understand? Last updated. So that when you want to do patch management, it is easier because you're not thinking, your head is not scattering. Where is this one? Where is that one? You know all the devices that you have. And when you buy a new device, it's very easy for you to go to that sheet and put in the new device, put in the operating system, and put in when last it was updated. Very simple. So we have patch prioritization. Yes, this is very important. Prioritize patches based on risk and criticality. Focus on critical and high risk vulnerability that have greater potential impact on your organization. Talked about this. Then test in a controlled environment. Yes, before you deploy, you must test. I've said this like 5 times now, and I will keep on saying it again. Before you deploy to your production environment, you must test it. Because if you don't test it and something spoil, you will have a lot of downtime and simultaneously lose a lot of money. And automate the patch the deployment. There are different patch management tools that can be used to automate and streamline the development process. So that might not have to be doing everything by yourself. There's even a way to group all your Windows devices together and do mass updates. Send the update across all of them. You understand? So there are different ways to automate this process because we at the beginning talked about how patch management is time consuming. Patch management sometimes is stressful. And then we talked about this, how it's sometimes stressful. You get so you have to look for ways to reduce this stress so that you can have time to do more important things. Then schedule patch management. Schedule patch deployment rather. So schedule patch deployment during maintenance windows or period of low user activities. I talked about how it's easier to schedule it maybe on weekends, on weeknights, when you know that a lot of people will not a lot of activities will not be on your services at that time. Then we have the rollback plan. Very important. Before you do any of your patches, right, ensure that your backup is correct. Ensure that you have a backup so that when in case you do this patch and something happens, you can roll back to before when this patch was implemented. Do you get? So make sure that your rollback plan game is solid. You understand? So that in case of incasities, you have something to roll back on. You get maybe that patch is not just compatible with your environment. Number three, we have user education. Educate end users about the importance of applying patches promptly and how to recognize legitimate update notification. Ensure a culture of security awareness. So for organizations where they have team members, where there are people that they've given company laptop to. So advising them, giving them training that when you see notification from Windows, you should do this. And train them how to identify the right patches. Because remember, we talked about how there are malicious attackers that will camouflage malwares as an update. You understand? So you need to tell them to be able to identify which one is the right one, how to identify that this is a right patch and they should implement it immediately. Understand? So number what? Number 4, we have document patch retirement. So maintain a record of patch retirement to ensure that outdated patches are removed as they may prove as they may pose security risks. So as new patches come up, some patches are getting outdated. So you need to know when to remove the outdated patches you get. And then patch management tool. Use dedicated patch management software to automate the identification, acquisition, testing and deployment of patches. Say it again, you can use a patch management tool to make your work easier, you get, and faster. Alright, so let's go to the Windows operating system. The Microsoft Windows is a family of operating system developed by the Microsoft Corporation to run personal computers called PCs. The Windows operating system was first announced in August 1985 as a graphical shell for MS-DOS in response to the growing interest in graphical user interface. So the first release of Windows 1.0, occurred in November 20th, 1985. Wow, a long time ago. It was a major improvement over MS-DOS in terms of friendliness and functionality. Alright, so since then, Windows have released many versions of Windows. We have Windows 2.0, Windows 3, Windows 3.1, Windows 95. It's how they jumped from 3 to 95 for me, and 98. I went back to 7. Is how they did it for me. And there's Windows 10, Windows 8, Windows 8.1, Windows 10, and Windows 11. Windows 11 is the latest one. A lot of people have been using it. I hope you are using Windows 11. Anyways, I think it came out last year. I can't remember. Alright, Windows is the most popular operating system in the world. With a market share of 70%, it is used by millions of people around the world for a variety of purposes, including work, school, and entertainment. Windows is a versatile operating system that can be used for a wide range of tasks, and it's a good choice for personal and professional use. I'm not trying to market Windows. I'm just explaining the reason why we are using Windows operating system as our example for this class. Not as market Windows, please. So Windows operating, almost everybody using Windows. There are, most organizations make use of Windows. Either you are giving your what they call it, either you are giving your staff members, your employees Windows, that's HP and Lenovo and Dell, and then installing Windows for them, or you go and buy Mac and give them. Most people hardly give Linux. But I don't think there's I hope hardly organizations, right? Only if you're a developing an IT organization, and Linux is so personally people use Linux for their personal selves and for servers. Yeah, people use Linux for servers. So basically that's just why we're picking Windows today. We want to dive into Windows because as a cybersecurity personnel, as a cybersecurity personnel, you'll be working with a lot of Windows, a lot of Linux, a lot of Mac devices, right? And depending on the attack, so attack can happen to anybody, it can happen to Windows, it can happen to Linux, it can happen to Mac. So the goal for today's class is just to get a little bit familiarized with Windows so that your inquisitiveness can take you to go and learn about Linux and Mac and the rest. Alright, so let's dive in. So what are the different components of Windows operating system? We have the device drivers. We talked about this. This is the driver that enables the operating system to communicate with and control the hardware devices such like printers, the graphics card, network adapters. We have the file system. The file system is responsible for organizing and managing files and directories on the storage device. So Windows make use of what? New technology file system, that's NTFS for storage. So the next thing that we have is user account and security. So Windows supports user accounts with varying levels of privileges such as administrator and the SATA user account. So Windows supports creating multiple user accounts. You can be an administrator where you control everything. You can just be a regular user. You get. Then there is a security feature. So inbuilt in Windows, you have your Windows Defender that's inbuilt. You have things like BitLocker inbuilt, where like it encrypts the disks. You also have like your firewall, Windows firewall for network security. So inbuilt in Windows, you have those things. In fact, when you get your Windows, you don't have to buy another antivirus. If you want to, you can. But your Windows Defender is strong enough. Then we also have networking. So we have your networking stack. With Windows, you can connect to your Linux, sorry, you can connect with your Ethernet cable. You can use your Ethernet cable to connect to the internet. You can use your Wi-Fi to connect to the internet. You get. So with Windows you can do that. And then there's something called remote access um what's it again? Remote access, right? So I can use remote desktop services. So it can allow you to do remote connection to other devices. You get. So you can use that. Windows allows you to use that. So what are the other components? We have the registry, the services, task scheduler, command prompt and command shell. So that's your CMD, your PowerShell. Then we have Windows management instrumentation. We have control panel. You know about control panel, right? And control setting and settings. Control panels where you do your configuration, sets where you do your configuration. When you want to set something, your brightness is not working. Why? Your speaker is not working. Why? All those things. So these are just basic components of Windows operating system. You will get to familiarize yourself with Windows. I'm sure each of us are using Windows. So just familiarize yourself with Windows. Get to touch some things, right? Okay, if I touch this thing, what does it do? That kind of, you try to get a feel of it because as as an engineer, as a cybersecurity personnel, right? You get to interact with these things. You get. So you need to just get a feel of it. There's this thing when a malware changes the memory of the computer system. So there's a point where you have to try and understand memories, right? How to read the memories. You understand? So those are very nice and very interesting stuff so that you can dive deeper into. All right, so let's get to very important thing, which is system management and diagnostic tool in Windows. Right. So what is this thing? It's a mouthful, right? So what exactly is this system management and diagnostic tool? So basically what it is that there are essential utilities that help user and IT professionals to monitor, to maintain, to troubleshoot and optimize Windows-based computers and networks. So basically, they basically provide insights into the system performance, the hardware health, and software issues. So the management and diagnostic tools are for troubleshooting, for seeing, okay, how is this device performing, for seeing how is this hardware performing, and all of that. So we are going to look into every one of them. At least we're just going to get the feel. All right, so the next first one is tax manager. I am very sure that we have worked with, we've done something about tax managing before. So most of the time, you go here when, let's say, your application is not working very well and you want to, so you can see all the things that's happening in your tax manager. Let's say this administration is slow, you want to right click and close, you can do enter, restart tax, collapse, all this stuff. So tax manager helps you. What does it help you to do? It helps you to troubleshoot. Task Manager provides real-time information about running processes, system performance, and resource usage. User can identify and manage application and processes. So with task management, let's see, you can see performance, real-time performance, right? You can see the real-time performance of your devices, your CPU, what is doing what. Do you understand? You can see all these things. With time, you'll be able to read and understand it, you get. But I'm just saying, with time you need to really understand it. Number two is performance monitor. So let's check it. Performance monitor. All these things are here on your device. So with this, you can see, okay, you can use the performance monitor to view performance data either in real time or from a log file. You get? So if you want to make use of these things, you can actually like read, look through it, understand it. So performance monitor allows user to create custom performance counters and log system metrics such as CPU usage, memory consumption, network activities. It is valuable for in-depth performance analysis. So sometimes, like when a malware can come and disrupt the performance of your particular device, you can use this as one of the things you use when you're trying to identify, okay, what exactly happened here on this device. There's resource, there's resource monitor. Let me see. Resource monitor, the same thing. You monitor your resources. Okay, this is what's taking my space. This is what's taking this is the process that is running on this particular device and stuff like that. Then very importantly, there's event viewer. I need to explain this one. So event viewer helps you see a lot of things, right? It helps you see logs. It helps you see logs. It helps you see things like application logs. Um, let me drop down. It's not showing here. Let me see. Security. Let me let me look for. Let me see. Yes, yes, exactly. So these are logs that are coming in. So whatever activity you do on your particular system, it logs something. So these are your logs that come into your system. You understand? So that so if something happens, you can be able to come here and check, okay, why am I seeing this error? What's this error for? You understand? What's this thing for? Why am I seeing this warning? With time, you'll be able to read, you'll be able to understand what's going on with time. But like when you are trying to monitor, when you are trying to do analysis, these are sort of things that you need to make use of. You get? So we have our system viewer. It displays event logs containing records of system and application events, including errors, warnings, security related events. It is for troubleshooting and monitoring. Then reliability monitor. Reliability monitor provides a timeline of system events, errors and application crashing. So let me show you reliability monitor. So it will show you a timeline. So reliability monitor, if it's to view reliability history, it will show you a timeline. So let's create a report now and to show you a timeline, right, of all the things that has been happening. Okay, why is this one bad? Over a period of time, you can be able to see, okay, I had two crashes today. Um, Windows did not shut down properly today. All this hardware error stopped working. So the settings stopped working around this time. Do you understand? Like, so the goal of this is to help troubleshoot. You understand? That's the goal. Then we have device manager. Very important. Device manager. This one is to help troubleshoot when, let's say, for example, all of a sudden you can't press anything on your keyboard. You can come and check whether your device driver is enabled. If you right click, you can see update drivers on install driver. So if, for example, now your keypad is not working, your keyboard is not working, you can come and check. Maybe your device was disabled or something. You can now either update the driver or something like that. Then what else? Let's slideshow. So we have this system information. So this one gives you a comprehensive report on the hardware, the software, and the system configuration details that you have. Then we have desk cleanup. So for example, now it helps you to remove unnecessary temporary file or necessary file just to give you space. Then there's the Windows memory diagnostics. So these two test system memory RAM for errors and problems. and hardware problems, right? Then we have the Windows updates, which is also very important. This is also used for batch management. So if you go to your settings, let's do Windows updates. Let's search for updates. Let's go to settings, updates. So it's here you will find your update. Check for updates. When you check for update, if there has any update, it will show the update and then install the update you get. So that is how to do your checks and all of that slideshow. So this particular system management and diagnostic tool is very important. It is so important that you make use of it for monitoring, make use of it to see the impact of a particular malware on a particular device. So if a device got affected, is this system diagnostic tool that you can use to help look into what exactly happened. So discussion for the class. What are the risks of not keeping system patched? So when you don't patch your system, what are your risks? What are the risks involved? Then what are the challenges that organization face when implementing patch management? So what challenge do you think that an administrator in an organization, a network engineer in an organization will face when trying to do patch management? Then what are the common system management and diagnostic tool for Windows? And have you used any of them? Have you used any? Have you used Task Manager? Have you used any of these tools? Right. All right. So any questions? Please drop your questions here. Be ready to answer them and discuss how organizations can use automation to improve their patch management process. Send it here. All right. Thank you very much for this class. Success with your quiz on Saturday. Have a very wonderful day. Bye.